Good morning, everyone, and welcome to this session, Go in Production. This morning, I've invited 4 members of the Go community and people who use Go in their companies' in production systems to talk to you about how they use Go and their experience with using Go. And so, without further ado, and the format of this panel is that we'll have 4 short presentations from the panelists, and then I'll open the floor to questions. And we'll have about half an hour worth of questions. During each of the slides, there'll be a little link in the bottom left corner, which will be to a Google moderator link. So if you want to enter questions there as you think of them during the talks, that's also a good idea. So without further ado, I'll invite my first panelist. He believes that the world needs better software, and he works at Canonical currently, where he works on the Juju project, and he's also built Landscape and the Storm ORM. As a Go contributor and a member of the Go community, he's worked on the Go core and the Mango MongoDB driver, GoCheck, GoAMZ, and others. Please welcome Gustavo Niemeyer. Thank you.
Thanks, Andrew. And thank you very much as well for the Go team for inviting me to talk to you and have a chance to describe why we believe Go is a better language for our workloads. So, Juju, I'm gonna quickly describe what problem we're trying to solve, and then I will describe how we're solving it, and then I'll go and tell a few bits about why Go is helping us in those tasks. So imagine you had imagine you wanted to deploy a service with a couple of, let's say, a couple of softwares, right? A couple of, either you have a database and your application, for instance, and you're doing that with, with a tool, sometimes with the help of a tool, or or by hand. So it usually goes like that. You get a couple of machines, you give them some names, and you develop some affection for those machines. And you put configuration files into those machines with, those configuration files generally will have details such as the IP address for, your database and information for exposing that service and details to interconnect to those machines. If you think about that, what you're actually doing is that you're creating a topology of services so that the things communicate with each other. But what occurred to us, which is really interesting, is that in most cases, that topology is actually in the administrator's head, right? You don't have that in the system itself. So this is all good, but then some issues started to occur, and for instance, it became a bit hard to give names, right? Can you imagine, for instance, giving like 600,000 names in the talk last morning? It's a bit tragic as well, because things, when you start to get a lot of resources, whatever those resources are, even if just a few are failing, you start to get lots of failures, and you have to deal with those. So the topology in that case becomes a little bit, complex as well. It's harder to get things together. It's hard to keep in our mind what's actually happening in the system. So this is really what we were after. We wanted to see not only how to solve this problem, but how to enable people to collaborate while doing so. And to collaborate, you have to reuse, you have to understand how to manage those resources. This is what Juju is about. When we were planning the system, we very much had the use case in mind. How can we implement that in a very straightforward workflow? We think a little bit about it as like up-to-get for services. You basically, for instance, Juju Bootstrap, it not only deploys the service itself, but it deploys the servers that run the service. And then you deploy a couple of services. You just say, deploy my application, MongoDB, for instance, and it will actually get those systems running on a service, on a machine, being managed. But Okay, but how do I tell the system that those two servers are communicating? We explicitly say add a relation between them. And the bits that are composed, the services, the charms as we call them, that compose the system, they have knowledge about how to establish that relation, right? So since that knowledge is within the system, you can start to do tricks like very easily add new units. You can add new bits to the system, and the system knows how to interconnect those bits to the rest of the system. Where is the topology in that case? It is inside. The system knows what's going on. Those bits are reusable, they're independent, and they're exchangeable so that people can deploy a better MongoDB, deploy bits of those systems, and everybody in the community benefits from that. So we're porting everything to Go. It was originally made in Twisted, in Python with Twisted, and we're porting the whole system to Go for quite a bit now. And we already have bits working in production, such as the database, the services themselves are served from. They're all running from Go. So why are we doing that? There are a few reasons. One of them, for instance, is error checking. One of the beautiful things about Juju, and the thing that really attracts people, is that it's kind of a magic system, right? You just type some commands and whoa, I have a service running. But magic systems can also break magically. This is a very sensitive subject, right? We want things to be running. We want people to not have to go after the issues and debug them. We want to reduce the chance, at least it's going to happen, but we want to reduce the chance of that happening. Go gives us a very visual way to say, here you have an error, do something with it. Another very interesting point for us was the fact that, for instance, when we requested a watch from Zookeeper, which is one of the systems we use in the backend, we get 2 futures back. Each one of those futures, the first one gives us the data, and the second one gives us notifications once the data changes. And that means that you basically have like 3 different paths that your code has to deal with, right? You have the first future that may fire, you have the second one, and you have the path that is the function that is currently executing. And then you have, but all of that is a single algorithm, so you have to take those 3 futures and you have to put them back into a single logic that makes sense. Go gives us a very straightforward path for that, right? You can just say, give me a watch, it can block until the data comes back, and the channel actually gives you a good way to wait for that information as well, in line, without having to go out. But that's really, I don't have time to go over each detail. Changing a language for a project from one side to the other is a very important decision. There are many, many small bits that would take a full talk to go over. So this is basically what we're doing. If you want more information, please, this is the URL. Andrew, thank you.
Thanks, Gustavo. So my next speaker is one of the first engineers at Heroku, and didn't respond to my request to send me a biography, and is also a great guy. Please welcome Keith Rarick.
All right, thanks, Andrew. I'd like to give you a quick story about one of the first production systems that we used Go for at Heroku. So first of all, what's Heroku? For those of you who haven't looked at it before, it's a platform as a service for running primarily web applications. It started out just as Ruby on Rails, but these days you can run just about anything, including Go. Right now we have about 1.9 million apps, and the company itself has about 85 employees. How Heroku works, just in a super short nutshell, is each app runs as a handful, 1 or more lightweight containers that we call dynos. And one of the most important pieces of Heroku is our HTTP front-end routing service. It has to have a table of all the processes that are running and where they are at any moment so that it can handle incoming user requests and send them to the right place. And of course, it changes whenever processes start and stop. For example, when a user scales up to more dynos. Now, not all of these 1.9 million apps are actually active at any moment, but a significant fraction are. And of course, it's changing all the time. So the way we've implemented this is we have a service to store just the routing table. It keeps the canonical copy of this table in a Postgres database. And it was originally written in Ruby as a RESTful HTTP sort of API in front of this database. So whenever the process manager starts or stops a process, it makes a call to this service to update its record. And then on the other side, whenever we start up a new instance of the front-end router, it connects into the service, gets an initial JSON dump of the entire table, and then after that, streaming updates so it stays in sync. So here's a picture of roughly what that looks like. Things go in from the left and come out on the right. And this works pretty great, especially because each front-end router has a complete copy of the table in memory, so it can do fast lookups with no IPC or anything like that. But there's a problem. And that's just that bootstrapping a new instance of the front-end router is prohibitively slow. And it turns out that that's just because of the Ruby process generating this initial JSON dump. So the guy who was working on this project, he had already used Go for a couple of experiments and smaller things, and he decided it might be worth taking a look to see if it would help out in this situation. So he decided he just wanted to make a drop-in replacement for the piece that generates the dump of the table and sends out streaming updates. And the nice thing was that he felt like he could just mess around in an afternoon to get a good feel for whether or not it would work out. And in just a couple of hours, he had a working prototype, which was very encouraging. So we decided to go ahead and make it into a real, clean it up and go through our normal testing and staging procedures. And so we finally deployed it to production initially alongside the existing Ruby process, but here's the new picture with the Go piece in place. And after running it for a while and getting operationally comfortable with this new piece, we flipped the switch. This was some time ago, so that the Go process is now the canonical one. And honestly, it was pretty much a win all around. First of all, it solved the initial problem that we set out to solve with more than a 10x speed up generating that dump. And in addition to that, it's just the ops burden is actually significantly less. We can just take that single binary and throw it up on a server, and it's easy to run, it's easy to manage. And that's actually been sort of a recurring theme. Sort of overall at Heroku, we've seen people sort of start to play around with Go a little bit on some smaller things or just on a side project, and then we've sort of adopted it for more and more things actually in production. So now we have a handful of systems running in production, and there's several more on the way in the pipeline. Thanks.
Thank you, Keith. So my next guest has written software for heart devices, video games, online dating systems, and mobile apps. Formerly the CTO of OkCupid, he's now the founder of Stathat. Please, I've done it in the wrong order. Oh my God. Since I've introduced him, he can start. Please welcome Patrick Crosby.
We've all listened to our talk so much, I probably could have done Evans. But so Stathat is a service to track statistics in your applications. You can add one line of code and you get graphs. You can track alerts and embed charts on your own site. For example, say you have an online dating site. One good metric to see if you have an effective site is to track if a user gets a reply to their message. So if you do something like change the matching algorithm and the reply counts go up, then, thank you, then the matching algorithm has gotten better. And Stathat's perfect for tracking something like this. So this is how you would track reply counts in the 15 different languages we support. We have Go, Ruby, Python, and all the rest of these. Once you add that one line, you get time charts showing the value changing over time, histograms showing the distribution of the data, and you can embed charts on any site. This is an example from GitHub archive where they're tracking every single GitHub event, and they show a Stathat chart on their main site. So you can track anything. Here's a bunch of examples, but basically any number in your code, any count, any event, you can send to Stathat. Almost everything in Stathat's written in Go. We use a standard net HTTP package for our web and data collection. Our backend all communicates over RPC, and we use a ton of third-party and standard packages. We often get asked why we chose Go. The main reason is that it's fast. Our services and request times are very low. And it's also fast to develop, and because it's statically typed, we don't have to write as many unit tests. It's also very resource friendly. Our server costs are much less than if we use something like Rails. It's an easy deploy system, which I'll talk about in a bit, and it's also a fun language to spend your time coding all day. It's a brief overview of our architecture. So the stat we talked about before, the message reply count, comes in over HTTP to our data collection servers, and it gets sent over RPC to the dataset services. Then the user interacting with the web service gets all the components from the various RPC services. And then we have some other Go applications that send alerts and email reports. Here's some details of the data collection service. Once the stat comes in over HTTP, it gets put in a cache right away, and we respond to the caller as soon as we can. Then there's a Go routine that serializes this cache to disk in case the server crashes, and another Go routine that takes data out of the cache and puts it in the update channel. We then have a pool of hundreds of Go routines that takes data out of the update channel and sends it over RPC to the dataset services. So deployment of Go applications is very easy, and the main reason is the binaries are self-contained, so there's no shared libraries, gems, or dependencies you have to worry about. And the Go tool also downloads any third-party packages for you and installs them. So basically, if you can get your app to compile, you can deploy it. At Stathat, every time we do a git push, it starts the deployment process. What this entails is it pulls all the code, runs all the tests, and compiles all of our applications. If all that works, it then makes a bundle and adds all the content resources. And then we have a web service where we select the servers that are supposed to receive this bundle, and it just rsyncs the bundle over and tells them that they have a new bundle and they should restart anything. And these servers don't have Go installed. They're just basic Linux installations. And this whole process to make the bundle takes about 2 minutes, and it's 100,000 lines of code. Stathat's an invitation-only service, but if you go to stathat.com/io2012, you can sign up without an invite. And we also have some open source Go code at stathat.com/src. Thank you.
Thanks, Patrick. And now I'll just jump back in my slides to the right spot, I hope. All right. So my final guest is the lead engineer at Iron.io. He was an early Go contributor and contributed the fast CGI and SMTP packages, and is now working on a book called Go in Action from Manning Publishing. Please welcome Evan Shaw.
Hi, I'm just going to talk a little bit about Iron.io and what we do and how we're using Go. So Iron.io builds cloud application services. That is, we build applications on top of cloud platforms like AWS and Rackspace, maybe Google Compute Engine in the future. And our main goal is to remove infrastructure worries. So most companies have a small set of problems that they want to focus on, and infrastructure is usually not one of those problems. And once we can remove these worries, we can enable smaller teams to do bigger things, which is another major goal of ours. So the first product we came out with is called Iron Worker. It's a massively parallel worker platform. So you upload your code or binary and then start sending us task data or payloads. And for each one of those you send us, we'll queue a task and then run it on our pool server somewhere. Our API for this service was originally written with Ruby on Rails, but it wasn't really keeping up with demand, not scaling how we wanted to. So we wrote version 2 in Go, and that made it a lot faster. We were able to take our roughly 30 Ruby servers and condense them down to 2 Go servers, and the second one is mostly for redundancy. We have a couple other products written in Go. One is IronMQ, a scalable message queue. It runs underneath Iron Worker and sends all your task data to the runners. And then Iron Cache, which is our latest product. It's a distributed key value store. Both these have RESTful HTTP APIs and text protocol support, Beanstalk in the case of IronMQ and Memcache in the case of Iron Cache. So here's just an illustration of the flow of data through Iron Worker and IronMQ. You send in an HTTP request, it goes through the API, and then we do a little processing there and put it on IronMQ, and we have all these runners, which is what we call the servers that actually run the job, pulling tasks off of this queue and then running them. So we serve a lot of HTTP requests at IronIO using Go, and the strategy that we use to serve those is generally by composing HTTP handlers together into a chain. So the first handler in the chain is typically authentication. We decide whether the request should be able to continue, and if not, it's unauthorized. If it is able to continue, it delegates to the next handler in the chain. Then we do something similar with statistics and usage. So each one of these handlers has a very specific purpose, and then it delegates onto the next handler until it gets to the end, which does the validation of the request and the database operations and finally serves the response. We don't use a lot of concurrency directly in our applications, but that's really kind of a testament to the good design of the Go libraries. So the HTTP package automatically serves requests and separate Go routines for us. We just have to make sure that our handlers aren't sharing any state that's not synchronized. For text protocols, we do run separate Go routines for each client, which doesn't require much communication. But we automatically get asynchronous I/O with that, which is really awesome. If we were writing this in Node.js, we would have all these callbacks while we waited for operations to complete. Or if we were writing it in C or C++, we would have to mess with epoll. It's just a big pain, but Go takes care of that for us in the libraries, and we can just write code the way we want to write it. So one other place we use concurrency is as kind of an optimization. Sometimes you have these actions in the request response path that don't actually need to be completed by the time you serve the response. So we can move those into a separate Go routine. Even less critical things can just have a dedicated Go routine that's kind of running in the background, gathering up all this information and batching it together into one request or one database update or whatever it is. So as an example of that first point, we have here an HTTP handler that is getting a project ID and then updating some statistics related to that project ID. And this is a somewhat expensive operation, noticeable if we keep it in the request response path. So in the after code, we've moved that into an anonymous function, put Go at the front and made it into a call, and now that code runs in a separate Go routine, and it greatly reduces the latency of this request. And this is something that's really cheap and easy to do, and we've hardly even changed the code. It looks almost the same. So why do we use Go? Well, for one, it's fast. It not only runs fast, but it compiles quickly. And I've worked on projects that take 45 minutes or an hour to compile, and it's not fun. It's still fairly expressive for a compiled, statically typed language. You don't tend to miss features from languages like Ruby and Python. It has a very rich standard library. If you wanted to operate with formats like JSON or protocols like HTTP and other languages, you might have to enlist in a third-party or non-standard library to get things done. But almost everything we need is built into the Go libraries. It's not tied to a VM, which makes deployment really easy. Go compiles static binaries with no dependencies, so you just drop it on a server, run it, and that's it. Nothing to really think about. And finally, Go is awesome. We have a lot of fun writing Go. And so I hope if you were harboring any doubts about using Go in production before this presentation, we've kind of helped dispel those doubts. Thank you.
Thanks. All right, so now I've invited the others back on stage, and if anybody would like to step up to the mic and ask questions of our panelists, we'd be more than happy to answer them. First person to do so gets a gopher.
The guy from Heroku, one question. Yeah, Keith.
Yes.
You're using Erlang as well at Heroku, and would you use rather Erlang versus Go? Because both languages do concurrency correctly. Like, they're one of the few languages that doesn't suck when it comes to writing concurrent software and reliable software.
How do we decide whether to use Erlang or Go for any given project? It's mostly up to whoever's working on the project. The most famous, the most well-known thing that we have in Erlang is the actual HTTP front-end routers that I was mentioning earlier. Those are all written in Erlang. And I guess the biggest reason for those is that that project was started before Go was, I believe before Go even existed, certainly before it was publicly available. And the team that maintains it they like Erlang and they don't feel like rewriting the whole thing. But yeah, it's pretty much a personal choice. I don't think we've started many new projects in Erlang lately.
So why?
Why? Well, it's hard to find Erlang developers.
Okay. So Go might be a bit more approachable to developers than compared to
absolutely.
Erlang? Okay. Okay, thanks.
Maybe you can say a little bit, or maybe each of you could say a little bit about your experience bringing new developers up to speed with Go, just leading on from that. Someone.
Okay, I'll go. Should I talk about hiring Go developers as well? Does that fit into this? Or?
Sure, whatever's most interesting.
So, since I've been working at IronIO, we've had, I think, a couple times where we've been trying to hire Go programmers, and we've been really successful with that so far. We just put out job notice on the invoice, and I think within about 2 days we had between 20 and 30 responses. Some not so good, but others very good, to the point where we had a difficult time deciding who to hire. No concerns there yet. We've also had a couple of developers who did not have any Go experience or did not have much Go experience come in, and we found it very easy to get them up to speed on how Go works and how to write it.
After this talk, it's probably going to get harder to find people.
Yeah, I just wanted to add that something that I've seen over and over again is talking with people who are looking at Go or thinking about it, or maybe they haven't even really looked at it carefully, but you can talk to them about a new language, especially Go. You can show them some examples, or you can say, oh, look, it has all these great features and it's easy to deploy and all this stuff. But then if you can get someone to actually sit down and write a page of code, spend 10 minutes actually using it, that's a whole different story. Then the light bulbs start going off, and then they are going on, and then they really start to appreciate it. But until that moment, that's usually a big turning point. It's like people look at it and they go, that looks interesting, it's pretty cool, and then they forget about it. And then you do it again, and they give the same response. But then when they actually start using it, then it's pretty different.
Yeah, and Canonical has been quite a ride as well. It's not like, even more if you have a good development body in the company, it's not straightforward to just switch languages. People are, sometimes they're passionate about the language, sometimes they're unwilling, they just don't have the time to try something new. So I personally find people all over the place, but I share as well Keith's feeling that when people do take the time to experiment with it and have an open mind about the benefits of developing it, I do see people switching over and getting closer to the language.
We'll take this question.
One of the common recurring themes we heard was that we used to use Ruby, and so I was wondering what's the Rails of Go, and what do you guys think about the packages and Ruby has a really huge community and a lot of different gems, and what do you guys think about the community around Go?
So there's kind of two questions there. Maybe Patrick's best suited to answering about doing front-end development with Go, because I know his entire stack is written in Go.
We did have a prototype that was in Rails, and we were worried about switching, mainly because of the plugins. We didn't want to write user authentication again. But then it actually took about an afternoon to write the equivalent of devise in Go, and so we haven't been spending our time on stuff like that. But it's actually very easy. The net HTTP package is great. All you do is provide a function that handles a route. And the template package is it's incredibly fast compared to ERB or something. So I wouldn't hesitate to try it. And I don't think there's a Rails there's a few other third-party packages for providing web services, but the standard net HTTP works great for us.
And does any of you want to speak to the Go community, the size or standard of? Well, I know that at least a few people here are active members of it, so it's
So the Go community, in a way, it's like we are the Go community as well.
Not in total.
Well, it's been growing, right? The packages are just like any other language. The quality of the packages are all over the place. The number of packages, we have quite a few of those. The core packages for our development, we pretty much find what we want, or we develop the missing pieces somewhat easily as well. In terms of the question about Rails or which platform to use, I share Patrick's view as well. The standard library is really good as well. It's the HTTP package, for instance. It's unlike other languages we've tried.
And I think the man in the glasses at the back there has a question.
Hi. One of the questions I've heard from people when I proselytize about Go is whether having a mark and sweep garbage collector in a systems language makes any sense. And I've heard, I push back a little bit, obviously, but I'm wondering if you guys are actually using it in production can talk about whether having a garbage collector in that language is an issue for you guys or not. I'm just curious.
Sir. It has not. The only issue we had is there is a bug using 32-bit servers with garbage collection. But once we found out that there was a bug and switched to 64-bit servers, we haven't had any problem with garbage collection. And
it's worth noting that issue is within a few weeks of being fixed entirely.
Yeah, one thing that I can say is we haven't yet used Go for anything that's highly sensitive to latency. But Heroku has a lot of pieces inside, a lot of different components that we're running in production, and honestly, very few of them are actually that latency sensitive. One example is something like our, this front end HTTP router that handles user requests. That matters. It matters that when a request comes in, it's not waiting for a GC pause. But the relatively few pieces actually depend on that particular kind of performance sensitivity. So for most things that we're doing, it's batch operations, it's background tasks, and it's not a big deal.
But have you actually observed any GC issues in what you're doing anyway? I mean,
No.
yeah.
Yeah, I think in our case it's similar. We don't have workloads with very low latency requirements. And I also feel a little bit like the speed of the language, the speed in which everything else executes, like dwarfs the garbage collection problems we might have. And I have to say as well that in fact, in some perspectives, I've developed quite a few C extensions for Python to speeding things up. And while the reference counting could be faster, it also creates a lot of issues in terms of leaks that are really hard to find, and it's always a hunt going after what's going on. So in that regard, we have C extensions as well in at least a couple of our packages, and we haven't had any such issues. So in that sense, the garbage collector actually helps us.
We'll take another question. Sorry.
So all of the presentations said that, well, Go is awesome. Could you share like some of either your favorite parts of it, or maybe things that your developers, as you've been ramping them up, are like, aha, that's so great?
Go Fumpt. That is my favorite part of Go.
I agree.
It's not a swear word. GoFumpt is the formatting tool that makes all Go code look the same, ending all the style wars about white space and brace placement and so on.
Yeah. More specifically, it's not just that it exists, but that I'm astounded at what a good job the community has done at sort of adopting it and sticking with it and consistently using this tool, and never having to worry about that stuff again is just, I don't want to waste that time.
Other parts?
So I'll kind of restate what I said earlier again. To me, there's no single feature of Go that I find, oh my God, this is so amazing, and I've never seen anything similar. Perhaps GoFumpt is a little bit, unlike anything else. But I think what's really fantastic about Go, and unlike anything else, in my perspective, is precisely the fact of all the bits together, how they make sense.
Yeah, I really agree with what Stathat was saying. It's hard to really single out any one thing that makes Go great, but if you really force me to do it, I would say the libraries. I think of all the languages I've used, those libraries, the core libraries are the best design libraries I've seen. The design feels very coherent, and if you are curious about how something works internally, it's very easy to dive in and start reading the code. It's very accessible code and good for learning Go as well.
Yeah, I want to echo that too. It's just systemic good design.
Thanks. Next question.
So I'm also using Go in production at SmugMug. First of all, I wanted to say thanks to everyone and the people who are on the Golang Nuts list. I've read a lot of your posts, and they're very helpful. Personally, the thing for me that I like about Go the most is it's impossible to get confused by most Go code. I can show it to other people I work with. It's always very straightforward, so I appreciate the fact that there's been a tendency to keep it simple. So two questions I have for the panel. One thing I noticed when I started building the proxy server I wrote was sort of a lack of a standard make-like tool. And there are a lot of them out there, and I'm just wondering, I just went with shell scripts because I couldn't really see one that had traction. Just wondering if there's a preference among the panel for build tools automation.
I think a lot of that's changed since Go 1. Go install basically does everything for you. We use that. It just go install Stathat basically.
Okay.
Yeah, and it's not even just the building part. It's there's a good, consistent scheme in which the libraries are organized. They're fetched from the network as well. So you can do like go get and URL with a command, and you get the command running, even though it has dependencies, it has build tools. So I find it pretty good.
Yeah, what they're referring to is, for those who aren't familiar, is there's a Go tool that ships with the Go toolchain. It's just called Go, and there are various verbs like go build, go test, go install, go fumpt, and so on.
So my second question was if there's anything from the libraries you would you think is missing that you'd really like to see?
I think I'd like to. I'd like to see there are certain things I'd like to see better done, perhaps. Like the SSH package is one that is evolving, but it's complex to get something that really works across all the cases in a consistent and stable way. So I appreciate the package. I want to see it being polished over time.
Thanks. Take the next question.
Hi, so this is just from the Google moderator, which is linked to from the screen. So Jason asked, and you might have covered this earlier actually, can you talk about how long it would take to learn Go?
How long does it take to learn Go?
I know I referred someone to the Go tour who wanted to learn Go, and they learned it within a few weeks, and they're now working somewhere programming Go every day. So
This is a tricky question, I find, as well, personally at least. I find that I never stop learning, so I'm still learning Go as well, even though I started like a couple of years ago, and I hope I don't stop learning. People can get up to speed with the basic language and productive, as Keith was saying, and just, if you're proficient with language, just a few minutes, you're going to be doing something. It's going to take a little bit longer for you to get used to the conventions and what it takes to get a feeling for what's Go proper. And it's learning to program in general. I mean, it's a lifelong task, I think.
Thanks. Next question.
Hi. I was wondering if you guys could share your experiences with other parts of the development tooling, like debuggers, profilers, even IDE support. How is that stuff? How easy is it to work with and use and help solve real problems, that kind of thing?
I can just comment briefly. When working on Doozer, the Go profiler was invaluable. It's one of the things that I don't have a whole lot to say about it, but it was nice. It was pretty easy to use and told me what I needed to know.
Yeah, so the profiler that comes with Go is a variant of pprof, which is a C++ profiling tool that Google built, and it provides graphs of memory allocations and also CPU utilization in a call graph kind of style.
Yeah, and one of my coworkers also said that he was very happy with the GDB integration. He was pleasantly surprised. And if you know him, that's an understatement. He was pleasantly surprised that it just worked, and it was really, really nicely done.
Take another question.
Another moderator question from Josh. What books on Go would you recommend?
Golang.org. Sorry, I haven't actually read any other Go books, but it's a good site.
I haven't read any Go books either, but I will point out again that I'm writing one. Sorry.
Next question.
Thanks. First, I'd like to congratulate the Go team on making something simple enough that the most interesting you can do is write useful code, which I think is a pretty impressive achievement. First, I'm interested in any advice you might have for people looking to deploy Go potentially into a high traffic environment in terms of I don't know, for instance, I like segmented stacks, but stack split boundaries, trying to avoid going over those. I know that there might be a performance issue associated with that, or scheduler being rather young. Are there any words of wisdom to avoid unforeseen consequences?
You mean to avoid trouble spots, essentially?
Yeah. Performance or reliability gotchas, effectively.
Maybe you can speak to it. But I was just going to say the general approach that I've seen inside Google is just write the simplest code that is obviously correct. And then if things start going pear-shaped, profile. And that recipe tends to work pretty well.
That's exactly what I was going to say. That's just what you do in general with programming. Yeah. You don't worry too much about performance at first. Just write it correctly, and then if you have performance problems, fix them, but only the places that you actually need to just profile.
It's good as well to have a good idea of what operations take, the basic timing of operations, right? Otherwise, because after you learn that, then you don't worry as much because you know what are the obvious things that will take a long time.
All right. Everything works as expected. Cool. Thanks.
Having used and worked with Go for a while, how do you feel about using it in like offline desktop type applications?
So this is one of the most fun recent projects that I've worked on at Heroku. So we have a command line tool called Heroku that has existed since the beginning of Heroku that we use, that all of our users use to interact with the system, to create new apps and to change their environment variables and do all of that sort of stuff. And it's one of those projects that it's been around for a long time, and it's quite a bit of code, and for a long time, so now it's well maintained. It has a great maintainer who's done a lot of good work. But for a long time, it sort of floated around without a clear owner, and it sort of accumulated a whole lot of code, and it got really slow and bloated, and it wasn't very fun. And so one of the things that another coworker did to sort of jumpstart, or at least compete a little bit and motivate work on the official command line tool is to make an alternative in Go just for speed. So there's a tool out there. You can find it on my GitHub, and it's called HK, and it's very simple. It's very similar to the existing Heroku tool, except it's written in Go, and there are a couple of other nice things too, like the fact that it's a single binary means that we can, the installation instructions are simple. You just curl this file down and stick it in the directory, and you've got it installed. There's no like downloading all these packages and dependencies and stuff like that. And in fact, because it's just a single binary, it took literally an evening for me to write, a self-update feature that, including, a nice binary diff, so that the updates are, a tenth of the size that they would otherwise be, and so it can periodically check to see if there's an update and download the update and apply the patch and ask you if you'd like to, yes, do you want this update? And then it just renames the file over top, and it's great.
I think the process you were describing is trolling-driven development.
Yes, that's what he called it, trolling-driven development.
Rewrite the bad stuff in Go. Do any of you have any thoughts on like GUI stuff? Because I said desktop applications. I guess none of you are really working on that.
No, I think where Go is really strong right now is in the server and backend area. I would really like to see desktop graphical applications ready to go, but I think the library findings are still young, and I know there's at least one effort to write a graphical toolkit in Go itself, which is really interesting, but that's young as well. And yeah, I recently saw somebody was written in a game in Go, which was neat, but I haven't had a chance to check out.
There's actually been more than one game. There's a few over the years.
Yeah, and I think I agree with what you just said as well. I'm pretty excited about being able to use a graphical toolkit in Go. I don't think the toolkits are quite there yet, but the concepts that Go allows us to use, they do make sense in a graphical application as well. So the concurrency aspects, the way that you can handle information asynchronously while waiting for data in channels and so on, this is useful in graphical applications as well.
Great. Are there any other questions? All right. Well, thanks everybody for coming along. And thank you very much to our guests. If we give them a warm round of applause. Thank you.